Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered if you can literally hear what you expect to hear, even if it is not really there? Well, this fascinating new study dives right into that mind-bending idea. Imagine listening to a song, maybe a catchy English tune, and suddenly you're convinced you're hearing words from another language, like Italian. It might sound crazy, but it happens. And scientists are trying to figure out why. This research explores how our brains create these auditory illusions, especially when what we expect to hear sounds a bit like something familiar from our own language. It is like our brain playing tricks on us, all thanks to what we've heard or read before. So, what is this predictive coding theory? Think of your brain as a superpowered prediction machine. It constantly tries to guess what's going to happen next, based on everything it already knows. When you encounter something new, your brain compares its prediction to what's actually happening with your senses. If Teresa match, great. Teresa mismatch, that's a prediction error. And your brain learns from it. This study wanted to see how these predictions work when listening to music, and if they could lead to actual illusions. The researchers focused on something called linguistic priors. These are basically your brain's preset ideas about language. If you speak Italian, your brain has a strong Italian framework. If you then hear English, your brain might try to fit those English sounds into your Italian framework, especially if the sounds are similar. This can lead to what they call false hearing words that aren't really there, just because they sound like something you expect. Famous comedic bits in Italy called canzoni travisate, or misheard songs, are perfect examples of this. To test this, they gathered 21 Italian-speaking volunteers who often used English. They designed a clever experiment. First, participants would read a sentence in either English or Italian. Then, they'd listen to a short clip of an English song. The key was that sometimes the Italian sentence they read was phonetically similar to the English lyrics they heard. This created the potential for the illusory illusion. For example, reading an Italian phrase that sounds like an English lyric could make them hear the Italian phrase instead of the actual English words. After each song clip, participants had to do two things. First, they rated how well the text they read matched the song lyrics they heard, focusing only on sound similarity. Not meaning second, they indicated if they recognized the song. While they were doing this, their brain activity was being recorded using EEG, which uses little sensors on the scalp to measure electrical patterns in the brain. They had 5 different scenarios to compare. 1, congruent English sang. The text they read was the exact English lyrics they heard. This should be a perfect match. 2, congruent Italian twin illusory. Sita, the text was in Italian, and it sounded like the English lyrics, even though it was a different meaning. This is where they expected the illusion. 3, incongruent English I. The text was in English, but it was from a different song, so it was a mismatch within the same language. 4, incongruent Italian Ita. The text was in Italian, and it was completely unrelated in sound and meaning to the English lyrics. This was a baseline for a native language mismatch. 5, scrambled words SU. The text was just random letters, meaning it had no real linguistic information. This was to see what happens with no expectation at all. One of the coolest things they did was train a computer program, a classifier, to tell the difference between brain signals from listening to English versus Italian from separate audiobooks. Then, they fed the brain signals from their main experiment into this program. What they found was striking. Trials where participants likely experienced the illusion, Sita, were more often classified as Italian. In contrast, the other conditions where the lyrics were actually English were more often classified as English. This computer program, listening to brainwaves, seemed to hear the Italian illusion even when the real words were English. So, the computer could actually detect brain patterns associated with Italian processing during those illusory trials. This provides strong evidence that the participants' brains were genuinely responding as if they were processing Italian even though they were hearing English. Now, let's talk about the brain signals themselves. They looked at early electrical signals called event-related potentials, or ERPs. Think of these as tiny electrical blips in the brain that happen in response to a stimulus. They focused on 2 specific ones, N1 and P2. The N1 is an early signal, around 100 milliseconds after the sound starts. It's thought to signal an early detection of something unexpected, a kind of, oh, that wasn't what I predicted signal. When the English lyrics didn't match the Italian prior, the N1 signal was a bit stronger, showing the brain noticed a mismatch. But in the illusory Italian condition, this early signal was a bit weaker, suggesting the brain wasn't as surprised. The P2 component, happening a bit later, around 150 to 250 milliseconds, is also linked to surprise and how much attention your brain pays to something unexpected. In conditions where the text and song didn't match at all, this P2 signal was quite strong. But in the illusory condition, where the Italian prior sounded like the English lyrics, this P2 signal was much weaker. This is a key finding, even though the lyrics weren't actually Italian. The phonological similarity to the Italian prior made the brain less surprised. It was like the brain was partially fooled, reducing the signal of surprise. This means that having a phonetically similar but incorrect linguistic prior could actually reduce the brain's neural response to surprise, because it partly matched what the brain was expecting. It's like your brain finding a shortcut or a comfortable fit, even if it's not the full reality. Beyond these electrical blips, they also looked at brainwave patterns or oscillations. In different frequency bands, two bands, beta and gamma, are particularly interesting for predictive coding. Beta waves are thought to be involved in sending predictions down from higher brain areas. Gamma waves, on the other hand, are more linked to detecting surprising information that doesn't match predictions, the prediction error signal. In the truly congruent English condition where everything matched, they saw more beta activity, suggesting strong top-down predictions. In the incongruent conditions, where there was a mismatch, gamma activity increased as expected for a prediction error. But here is where it gets really interesting, in the illusory condition. They didn't see the same strong gamma response as in the purely incongruent conditions. Instead, after an initial moment, beta activity became dominant again and earlier than in the incongruent condition. This suggests that instead of a big error signal, the brain in the illusory condition actually tried to assimilate the incoming English sound into the Italian expectation. It's like the brain saying, "This kind of sounds like Italian, so let's just treat it as Italian." This leads to a dampened surprise signal, allowing the illusion to take hold. The beta dominance returning suggests the brain reinstated its predictive processing, but now based on the illusory Italian input. So what does all of this mean? This study powerfully shows that our expectations, especially those driven by language, can literally change what we hear. Phonetically plausible but false linguistic priors can indeed create cross-linguistic auditory illusions. The brain's surprise signals are dampened when these illusions occur, suggesting a process of assimilation rather than a strong correction of a prediction error. The fact that a computer could predict the perceived language from brainwaves when the sounds were ambiguous is pretty mind-blowing. It highlights that these illusions aren't just weak perceptions, they involve genuine neural activity patterns associated with the perceived language. It means our brains are incredibly good at filling in the blanks and making sense of the world based on what we already know, sometimes to the point of creating entirely new sensory experiences. However, it is important to remember this study had limitations. They used a full sample for analysis, and it would be interesting to see if they could separate participants who truly experienced the illusion from those who didn't. Also, they focused on early brain responses. Later brain responses might offer more insights into the full journey of how these illusions are processed. Future research could explore how things like musical training or how difficult the task is might change these illusions, and, of course, how these findings relate to clinical conditions where predictive coding might be altered is a very exciting avenue for future exploration. This research gives us a fascinating peek into the predictive machinery of our brains and how flexible and sometimes fallible our perception can be. It makes you wonder about all the other subtle ways our expectations might be shaping our reality, both audibly and visually. Thanks for joining us on RUBIN'S Mind Lab. If you enjoyed this dive into the science of hearing, please give this video a thumbs up. Leave a comment with your thoughts below, and don't forget to subscribe for more brain-bending research. See you next time.